Welcome to Kinematics. Before we can investigate the forces that cause objects to move, we must first build a rigorous mathematical language to describe exactly how they are moving. This unit provides the fundamental vocabulary and toolkit required to analyze objects in motion, from a car braking at a traffic light to a satellite orbiting a planet. You are transitioning from everyday concepts of distance and speed to precise vector definitions. This foundational knowledge is critical as it underpins almost every subsequent mechanics topic in your Cambridge International A-Level Physics course.
Our first topic is the equations of motion. Here, you will master the four formulas for uniform acceleration, commonly known as the Suvat equations. You will learn to precisely define vector quantities like displacement, velocity, and acceleration. More importantly, you will use them to predict the exact future position and speed of an object. In your Paper 2 exams, you will face structured calculation questions where explicitly stating your sign convention is just as important as calculating the final answer. Remember, these equations only work when acceleration is strictly constant.
Next, we translate physical events into visual data with displacement-time graphs. You will learn how to read an object's exact velocity simply by calculating the gradient of the line. We will also tackle complex curved graphs that represent accelerating objects. Here, you will learn to flawlessly distinguish between instantaneous velocity, found using a tangent, and average velocity. These visual tools frequently appear in Paper 1 as tricky multiple-choice distractors, testing your deep conceptual grip on how position changes over time.
Topic 3 introduces the velocity-time graph. Think of this as your central dashboard for kinematics. You will extract an object's acceleration directly from the steepness or gradient of the line and calculate its exact displacement from the area underneath the graph. If you can read a velocity-time graph fluently, you can often bypass pages of complex algebra. In the exam, drawing a quick sketch of one of these graphs is frequently the secret first step to unlocking a difficult 10-mark mechanics problem. Finally, we extend our one-dimensional toolkit into 2 dimensions with projectile motion. You will analyze objects launched through the air by treating their horizontal and vertical components completely independently. The golden rule here is that horizontal velocity remains constant, while gravity accelerates the object vertically downwards at 9.81 meters per second squared. Mastering this separation of dimensions is vital. It is a guaranteed high-mark question in Paper 2 and forms the mechanical foundation for later topics like electric fields.
To sum up, this unit builds your core mechanical foundation. You will confidently define the vector quantities of motion, extract vital data from the gradients and areas of kinematics graphs, apply the constant acceleration equations to solve complex problems, and conquer 2-dimensional projectiles. Let us begin building your mathematical toolkit.